to work with square root functions and the graphs of those. And so here we have an interesting little word problem where we can actually learn a few things, maybe not necessarily math related. So let's read through this. As the frequency of vibrations for a certain guitar string when it is plucked can be determined by F equals 200 times the square root of T. Now you might say, well, what does F stand for? Well, I'm glad you asked. Where F is the number of vibrations per second of the guitar string, and T is the tension on that string measured in pounds. Graph the function for 0 is less than or equal to T, the tension, and T, the tension, then is also less than or equal to 10. And then determine the frequency, number of vibrations, based upon the tension when tension is either equal to 3, 6, or 9 pounds. Now, if we think about this function here, there's something that we can see. The greater the tension, the greater the number of vibrations. Because if we look at that, if I put in the square root of 3 for T, we got 200 times the square root of 3. That would be the number of vibrations, or 6, square root of 6 times 200, or square root of 9, which is 3. That means that 3 times 200 is 600 in this model. There's 600 vibrations per second on that guitar string if there's 9 pounds of tension on that string. Kind of interesting to think about that. Those of you maybe that like to play the guitar, or maybe the violin, or the cello, or the bass. Okay. All right, we're going to go over here to the graph, to our calculator, and we're going to graph these because there's an interesting thing since we've got this statement right there of how we can graph that and then use zoom fit and all that. We'll see what we're talking about here momentarily. All right, we're over here on the calculator and we're going to graph that function as it was described to us. Let me clear what I've got out here beforehand. We'll clear this. And so we've got a function that we say that is 200 times the square root, second x squared square root of, we're going to use x instead of t. And then we got to put some limitations on this. And so I'm going to hit second parentheses, which gives me a bracket, so that 0 is less than or equal to t. And so to get to that, I'm going to hit second math, which takes me to the test functions. And I'm looking for less than or equal to, which is 6. And then I'm going to substitute x for t. And then we got to put our second restriction in here, second math again. I'm going to choose option 6 again, and now this is 10. And I need to close my bracket, so I'm going to hit second right parentheses, which gives me a right bracket. All right, so before I graph this, I think what I want to do is I'm going to hit zoom, because if you think about it now, we'd already established that at 9 pounds of pressure, that's going to be 600 vibrations per second. My Y values are going to go off the scale. So I'm going to go zoom fit, I think, which I think is zoom A, if I'm not mistaken. No, zoom 0. So I'm going to hit enter. Let's see what happens with our graph. Okay. I'm going to go in my window and I'm going to change that because I'm going to move my X values down to 0. I'm going to look at it based on that. Now let's go look at the graph, see what we got. All right, so there is our graph. It looks just like a square root function, doesn't it? Now, let's see, we were asked to find what's the frequency when we got 3 pounds, 6 pounds, and 9 pounds of tension on that string. And so I'm going to go to my table. I'm going to hit second graph or table. And we're going to scroll down here. And so let's see, when X is 3, which represents 3 pounds of tension, our frequency, our vibrations per second is 346.41. Now, how about when we go to 6? Well, that's 200 times the square root of 6. and our frequency would be 489.9 vibrations per second. And how about when our tension is 9? We'll Shazam. When we've got 9 pounds of tension in this model, our frequency of vibrations per second of this guitar string, when it has 9 pounds of tension on it, is 600, which is exactly what we would expect, because the square root of 9 is 3 times 200, 600. Shazam! We've done it. All you musicians, get up and give yourself a cheer.